I'll be talking on different solar power system components that are used for solar inverter system installations. So we know that we have different types of solar modules, we have different types of charge controllers, batteries, and inverters. All this depends on manufacturers, then the purpose of which they are being used for. Then it depends on your configurations. It depends on how you want the efficiencies to be. And sometimes it depends on how buoyant each customer is. So all these components, I'm going to talk about them briefly. It may not be deep, but at least to introduce us to different types of modules and materials. As you can see, we have different types of solar module depending on the material of which they are made of, and different types of charge controllers, as you can see, depending on how you configure your system. Then we have different types of batteries, ranging from maybe the front end loading, the tubular battery, the AGM batteries, the lithium ion batteries, the lithium ion phosphate batteries. Different types. We have different types of inverters too, ranging from we have the square wave, we have the sine wave inverters, different applications and where they are suitable. We have the standing ones, we have the wall mount, we have the tabletop types of inverters. So all these I'm going to introduce us to them. Solar power energy components. As we know that if you want to install solar energy in your house, there are some basic components you needed, and that one will be from the solar module, the charge controller, the inverter. All these components have their own usage and then connection and their importance. The first one to consider is the solar photovoltaic cell module or panel. As in the last series that I did, I made mention of module, trying to differentiate a cell. A cell form a module, the connection of cells will form module, and connection of module will form a panel. Then we have array, that is when you have so many panels that you form into strings and to form an array. Then silicon is the most abundant material for solar cells construction. Silicon is used for solar cell construction, that is a cell, before you arrange them to form a module. Then we have also the different types of materials we use for these photovoltaic cells are cadmium telluride, that's a combination of two materials, gallium arsenide and copper, indium gallium selenide, etc. They are used for these cell constructions. And the three main classifications of silicon solar cells are monocrystalline, polycrystalline, and thin film or amorphous silicon solar cells. Those are the three major ones, of which we now have some newer type. I won't say new type. We have the pack solar cell, that is a passivated PERC for pack. This passivated emitter and real cell. We have the bifacial solar cells that you have that stores energy as both, that have solar energy cells as both front and the back. So you can generate energy from both front and the back of the solar panel. Then we have some half-cut solar cells, but the major three classification of solar cell we have the monocrystalline, some people for short call it mono. We have the polycrystalline, the thin film, and then the amorphous silicon solar cell. And all these types are based on their construction and the materials they are used. So the monocrystalline solar cell, it says they are formed into bars and cut into wafers to make monocells, and that's how they were formed. Are you getting it? So, and one of the advantages or some of the advantages that they are the most efficient and they are the most usable ones that we can find around because of their efficiency, and they are very expensive also. So all these ones depend on the material and the way they were constructed. So they are most expensive, and when you see them, you can see the cells. They are like, can I say maybe a diamond? You can see how they are formed. So they are the most expensive, and their efficiency lies between 15 to 20%. In some books or in some journals, some may rate them maybe 16 to 21%. It depends, but averagely between 15 and 20%. They are the most efficient ones, and they are most expensive also. Then you can see the polycrystalline structure. Usually their color is in blue. Yes, and when you see the pattern like in a scale form, you will know that, oh, this one is polycrystalline. And they are fragments of silicon and melted together to form wafers. That's the way it is constructed. And it's less efficient than the monocrystalline, and it's less expensive. And you can see the efficiency. The efficiency lies between say 13 to 16%. So it's the mode of construction that differs from the monocrystalline. Then we have the other one, that is the amorphous one. And this amorphous one, the thin film, some call it, they are flexible. They use them for some use them for maybe some road construction. They are very flexible. They are least efficient. That doesn't mean that they don't use them. They have their own area of application, and they are least expensive. And maybe you have seen some that are really flexible. Yeah, you can bend them. Those are the types of thin film and amorphous silicon solar cell. So the PV materials are deposited on supporting material like glass or metal. That is the PV material. The material they use for them, they are deposited on a special material that you want to use as a supporting material. So those are the three main types that we have. You see, you have mono, we have poly, and we have thin film. Apart from the aforementioned one that I said, the pack cell, the bifacial, then they have got solar cells. And solar charge controllers. These are electronic devices used basically for regulating the voltage and or current from the solar panel to keep the battery from overcharging. And the solar charge controllers, we call them controllers because that's where you connect the output of your solar panels directly. The outputs, as you know that our solar panels or the photovoltaic cells generate DC, electrical current. That is, we have DC directly from the solar panel. And we know that our sun is intermittent in nature. It fluctuates. Are you getting it? So you need something like a regulator, some call it regulator, to regulate the amount of voltage and current coming from the solar panels into your system. As we know that depending on your configurations too, we have something to charge your battery, and you know that our battery is the storage. Uses for energy backup, uses as energy storage. So charge controller, basically, some call it their boost converters, they are buck boost converters. So they are converters too. You getting it? Because it's a DC to DC converter. I can say it's a DC to DC converter because during the intermittent nature of the sun, the different voltage is coming from the solar panel, or varying current or varying voltage coming from the solar panel. It's the solar charge controller that will stabilize the amount of voltage, the amount of current going into your battery, so that your battery will properly charge, and it will keep your battery from overcharging. So it prevents excessive battery charging, it prevents overcharge, over discharge, provides status information. You will see the current coming from the solar panel, you see the voltage coming from the solar panel that charges your battery, and some will even display the amount of wattage in kilowatt hour that is coming from the solar panel too. And charging set point, what I mean by charging set point, in some charge controllers too, you'll be able to set you'll be able to set, maybe it's a flooded battery, maybe it's a VRLA battery, maybe it's a lithium ion battery, maybe it's a lithium battery. You'll be able to set accurately the charging voltage, the charging current, and that's what I mean by the charging set point. So we have two major types. The one we call MPPT, that is maximum power point tracking, and the other one we call pulse width modulation, that is the PWM. MPPT, it operates maximum power voltage and delivers maximum available power to the system. What we mean by this one, the MPPT, is that it will track the maximum power from your solar panel or photovoltaic cell. It will track the maximum power from the panel to use it to charge your system efficiently. For the PWM, we operate at battery voltage, and you will see in some literature they say it will charge a little bit above the battery voltage, and this is not that efficient. So that's why some people choose MPPT over the PWM. And this first picture is the PWM type. You can see the panel comes in first, the battery, and the load. The load is not really mostly useful, because in my country or in some other part of the country we use AC. So unless you are using a DC load, then you will be able to use the load port on the charge controller to control. Maybe you have a DC bulb or a DC appliance you want to connect. Then this type of charge controller is a string enable charge controller. What do I mean by that? They usually have like 3 ports, though the port is covered. For instance, if I'm having a 6 module and then I want to connect in two strings, that is 3 together, maybe in series, another 3 together in series. So the first 3 will come as a string, plus and positive and negative side to one of the ports here. Then the second 3 I connected the series will come into the charge controller second port. Then the third port will be for the battery. So these are regarded as a string charge controller. Then this one too, they are MPPT charge controller. Then this one too is an MPPT charge controller, and we have some that are regarded as fan cooling. You understand? Because some are regarded as heat sink, and some are regarded as fan cooling. The fan cooling, whenever maybe the system gets heated up, then the fan will pick up automatically just to cool the charge controller. Then the energy storage, as we know that we need an energy storage for our system, and the purpose of this energy storage is after the sun sets, maybe in the evening, and you have something to fall back on. So it's the battery, the energy is the battery that will supply electrical energy during the night when there is no sun. The main energy storage here is the battery. The battery is an electrochemical cell which stores energy in chemical bonds. The chemical energy stored is converted into electrical energy when load is connected. The energy produced by the PV array is stored in the battery. Yes, and as I've said, the output of the photovoltaic cell, that is maybe your module or your PV array, the output is direct current, that is DC. And it's this DC that is fed into the charge controller, and the charge controller use appropriate charging voltage and current to charge your battery. And when your battery is being charged, automatically is storing energy. And this chemical energy that is stored will be converted into electrical energy to power your loads when the sun sets or when there is no sun, again, most especially at night. And we have different types of batteries or battery chemistries used for solar system. We have the valve regulated lead acid, we have this SMF, that is seed maintenance free. We have the AGM, that is the absorbent glass mats, is the types of battery. We have the lithium ion, we have the lithium ion phosphate battery, we have the tubular battery. All these have their chemistries and then areas of applications. So this type of batteries, we have so many of them. The front one is, all of them are lead acid battery apart from the lithium ion. The first battery is front end, then some are gel. We have some that we regard as gel battery. We have some that are lead acid battery. The second one is SMF, that is the seal maintenance free battery. Don't touch them. Then the tubular, you can see the cell indicator. The electrolyte cell indicator, that's the tubular type of battery. It's not a free maintenance one, but it's regarded a little maintenance because you top them with distilled water when the electrolyte content gets low. Then the lithium ion batteries is the last battery there. We have some lithium ion, then some lithium ion phosphate battery. And because this lithium ion is different from others, because most of them, they have their own depth of discharge between 90% and 95%. That is, we can deplete them. That's the advantage they have over other types of battery, because other types of battery like the SMF, the VRLA, the tubular batteries, their depth of discharge, that is the DOD, most of them ranges between 40. Even if hardly will you have 40, most of them like 50%. Then the solar power inverter. Inverter is an electronic device that changes direct current, DC, supplied from the PV panels or battery to an alternating current, AC, to power the electrical loads. Inverters are classified as, what I mean by inverter are electronic devices, they comprise of electronic devices that they are built together, like the MOSFET, the FET, the transformer, and that changes the direct current. The direct current that is supplied from the battery, or some, depends on the types of inverter, maybe hybrid, some don't even require batteries, some have inbuilt charge controller, some don't even have that, they are grid tied, that they just convert the DC current directly from the PV array into an electrical current. So we have different types of inverters, but all the same, they are still electronic devices that changes direct current, whether it depends on electrochemical set to supply the loads or not. It changes direct current supplied from the PV batteries to an alternating AC to power electrical loads. Inverters are classified as standalone inverter. We have a standalone inverter, or they are regarded as an off-grid inverter. They are designed for remote application of off-grid power system with battery backup. The battery draws its DC power from batteries charged by PV array, most applicable where utility grid is not available. Maybe you have a local community that they don't even have supply from the national grid of that particular country. So the type of inverter we use there are standalone because they derive their source from backup batteries that is being charged by PV array during the day. So those are the types of inverter used where grid is not available, are known as standalone inverters. The grid-connected inverter or grid-tie inverter, they are designed for applications which does not require a battery backup. It converts DC power produced by PV array to AC and supply excess energy back to the utility grid. This type of inverter I was saying earlier, like you see that this one does not require any battery backup, so they are termed grid connected inverter. So it converts the DC produced by the PV array directly into an AC and supply excess energy back to the utility grid. So these types are regarded as grid connected inverter because they are tied with the grid. They relate with the grid. The PV array is the one that produces the DC power that is used to convert directly into AC. So it's not the battery that produces the DC current into the inverter to be converted into AC. I think you get the difference between the grid connected inverter and the standalone inverter. Then the grid interactive inverter is designed for residential, commercial, and industrial applications. This type of inverter operates on both grid-tied and standalone off-grid application. The DC power generated by PV is converted to AC power to supply the load, while excess energy is sent to the grid when the utility power is normal. Then when utility is unavailable, the inverter operates as a backup source to supply power from PV and battery. So this one is regarded as grid interactive inverter. It uses both. It can start at both on grid tied and standalone. So it combines both the standalone inverter features with the grid connected inverter. So it has a battery backup, and it can be when the utility is not available, then the inverter will operate as a backup and supply power from PV together and battery. So these are types of inverter we can see. Some can stand on their own, some you can place them on a table or in a stool, some are wall mounted, you can mount them on the wall. Some you can just put them by the side. So we have different types. It depends on different manufacturers, and it depends on what you want to use and area you want to install them. Then another thing that is that we have some types of inverter that we know they are sine wave, pure sine wave. You can see some, they call them a modified sine wave. You can see square sine wave, but mostly what is good for appliances are sine wave inverter, pure sine wave inverter, because square wave are not good for our electrical appliances, apart from maybe you want to use them industrial setup, like maybe for electric motors and stuff like that. So another one is the string inverter, and this is the commonly used in our home and commercial solar power system. A string inverter is connected to a series of string, and that's what we use mostly at home, because we have, what do you mean by strings? String is like, maybe I have, as I've said earlier, I have like 6 panels, then I connected them in strings, maybe in 2 2 2. That will be making 3 strings. Maybe I connected them in series, two in series, two in series, two in series. So I'm having 3 strings already. Are you getting it? So then connect them maybe into my charge controller. I getting it? And then connected to my battery, and my battery connected to my inverter. So these are called strings inverter because you connect your solar panel in strings. Then we have a micro inverter. This is a small box that is attached at the back of inverter. They run independently, and it monitors performance of individual panels and operates independently. Yeah, they monitor the performance of individual panel. If one cell is shaded, it's not affecting the other panel. So they produce their voltage maximally, not optimally. Then this is type of string inverter. Usually they are found or attached at the back of each panel to monitor the performance of each panel. Should any panel be shaded, it won't affect other panel or module. Then hybrid inverter. Some are the combination of inverter and charge controller, while some works with renewable and traditional source of energy. This hybrid inverter, I will say, are in 2 forms to the best of my knowledge. We call some hybrid inverter as we have some components. As I'm explaining some components, the basic components of an inverter, solar inverter system installation, is for you to have a PV panel. That's one, a charge controller. That's two, your inverter, your battery. But some we call them hybrid because you don't have to purchase another charge controller. They have inbuilt charge controller. So some of them are regarded as hybrid. But another types of hybrid we have is there is input for gen. You can use them with renewable and traditional sources of energy. Traditional sources of energy will mean that you connect a diesel generator or a petrol generator with them. Then you can connect them, then you connect a grid with them. Then you can have a wind energy. They can have a source of a port of wind energy on them. They can have a port of solar energy on them. So it combines both renewable and traditional sources of energy. And how does it work? It means it will balance. For instance, if you are consuming a 10 kilowatt of energy, maybe in your industry or in your home, then the solar panel is generating 5, maybe the wind is generating 5, and then when there is intermittent supply, maybe from the solar panel or from the wind, maybe they are generating 4 each, then you have a deficit of 2, then the gen will come automatically to produce the 2 extra kilowatts needed for your consumption. So that's how it works, and those are the two types of hybrid inverter. One that has an hybrid that has an inbuilt charge controller, and the other ones that work both with renewable and traditional sources of energy. And from this picture, you can see that the solar power option is in there, a generator or utility is in there, then battery pack is in there to power your home appliance. I can say solar power disconnects. These are used to interrupt or complete the flow of electrical current. They can be used, to the best of my knowledge, they can be used as a protective device also, because they make and break the flow of current. So we have both DC and AC disconnects ranging from switches, breakers, used purposefully to protect the solar inverter system. So these examples are breakers. You can have some SPDs too, that is the surge protective devices. So all these one are just to interrupt the flow of electrical current. Maybe you want to perform some maintenance, or maybe there's fault on the system. Automatically it breaks to protect the system from damage. And these are example of the switches. The second one is the breaker. The third one is the SPDs, that is the surge protective devices that caters for lightning surges. And the solar power metering. The solar power meter is used to measure the energy consumed and produced by a system in the house. Yeah, so it meters, that it records the total energy you consume or you produce, and there are some that we regard as prosumer. You understand, they produce and they consume. Maybe you have some PV array on your roof, you produce, then maybe you even sell to maybe the government, sell to the national grid. So it also measures the energy from the grid and send the information to the provider. If you produce, for instance, maybe you are generating more than you consume, then you sell to the national grid, and then maybe at the end of the month they will give you some profits. You understand? So that's how it works. Like this picture is telling me that I have a rooftop solar I generate. Then this is a bidirectional electric meter. It monitors the power you consume to produce. It monitors the power you produce or generate. It monitors the amount you sell to send to the national grid. Then it monitors what is coming from the grid even into your system when you are not generating, or maybe when your the amount of energy you generate is less. Then we can go on and search about net metering also, and that's another billing mechanism that monitor the amount of energy you produce and compare with the energy you consume and what is coming from the national grid also. So all these are just the basic components that is needed when you are doing your solar energy system installation. Please do like, comment, subscribe, and share for more renewable energy technologies and do it yourself projects. Thank you.